Here is the solution to the SHM basic mass on spring 10-mark question. That's January 07, question 3. Defining SHM then, I would say an object is in simple harmonic motion when its acceleration is proportional to its displacement from the equilibrium position and always directed towards the equilibrium position. Now you might say that could be replaced with it, and maybe it could, but I like to be completely unambiguous in my answers. So, 120 gram mass performs simple harmonic motion when suspended from a spring that has a spring constant of 3.9 newtons per meter. There's a missing -1 in there. Calculate the period t. Well, we have the mass, we have the spring constant, we want t. We know that t is 2 pi root m over k. So let's stick that in. So we know that the period will be 1.1 seconds. And again, don't forget your units. Never forget your units. 1.1 seconds. The simple harmonic motion is started by displacing the mass 15 centimeters from its equilibrium position and then releasing it. Calculate the maximum speed of the mass. So the first thing to realize is that this 15 centimeters is the amplitude. And so we want the maximum speed, the maximum velocity, and we know that v is, maximum v is 2 pi fa. So if we stick in our numbers then, we'll get an answer of 0.86 meters per second. Because I should have said frequency is 1 over the period. So we know the period is 1.1. 2 pi a over t then gives us maximum velocity, and that gives us 0.86. Calculate the maximum acceleration of the mass. Well, we know that acceleration is minus omega squared x, and the maximum acceleration will be minus omega squared a. So we know that omega is 2 pi f, and f is 1 over t. So that's minus 2 pi f all squared times a, which is minus 2 pi times 1 over 1.1, our period, all squared times 0.15. And that gives us an answer of 4.9 meters per second squared. And then finally, we're told that the 120 gram mass is replaced by a block of wood, and we're told that the period then changes to 1.4 seconds. So I'm not sure where the rest of my question has gone here. Just give me a moment while I try to pull that back up again. There we go. Not sure why I couldn't scroll, but there we go. So what do we know? Well, it's the same spring, so the spring constant's going to be the same. We have two periods, 1.1 seconds and 1.4. The only difference is the mass on the spring, and we want to know the mass of the wooden block. So the way that I'm thinking is I have an expression for each of the periods. I've got T1 is 2 pi root m1. I'm sorry I can't make this a subscript underneath the square root sign. And T2 is 2 pi root m2 over k. Now I know T1, I know T2. I don't know k, but I know m1, the original mass, 120 grams. So I can now say that the ratio of the periods, T1 over T2, equals the ratio of the masses, square rooted, m1 over m2. So I know, I'm going to stick this next to this if I can. I know m1 over m2 is the root of 1.1 over 1.4. So if I rearrange that to make m2 the subject, I get m2 is 120 times the square root of 1.1 over 1.4 over 1.1. And that gives me an answer of 180 grams, which I'll have to make this a bit smaller to see. So there you go, 190 grams is your answer there.